Hello everyone, in this tutorial we are going to learn how to build our first regression model using gretl. So after you run gretl, this is the main page that you will see. Go to File, Open Data, User File. And after that you need to come here and click on this arrow, and after that select all files. And the file that you need to use here I already attached with this tutorial. Let's go to the location that you saved that file in. The name of the file is dataset1.xlsx, which is an Excel file. Double click on that file and you already will get this window popped up for you saying that you have one column and one row. Click OK. And as I mentioned, that gretl is a very convenient software that's telling you already they found one valid sheet, because in that Excel file we have only one sheet, and also it is telling you that it found 2 variables and 10 observations. So in advance they give you how many variables that you have and how many observations you have also. Click on close and click no, because we don't need any time series, is not part of our work here. So click on no. It gives 0 for the constant, 1 and X for the experience years, 2 Y for the monthly salary. So figure out that this is X and this is Y. So what we need to do right now is to create a simple linear regression, because we want to find what is the impact of year of experience on the monthly salary. And to do that you need to come here to model, click on the model and click ordinary least squares, because this is the method that we need to use to create the simple linear regression. Click on it and you will see here this menu, and this is very similar in many statistics applications. It's almost the same thing in all of them, because it's mainly show you here in one window all the variables that you have and what the variables that you want to use in your regression. So first thing here is the dependent variable, and you know that dependent variable here is the monthly salary. That's what you need to figure out or predict based on the independent variable, which is the years of experience. So click on this arrow and already now it's already become a dependent variable, and you can set it as a default because this will not change in the future. Even if you want to change any independent variable, this variable will stay as a dependent variable. And already constant or the intercept is here. So only thing you need to do is just to click on the experience years and click on this green arrow. And if you want to remove it, you simply need to click on this red arrow to remove it. So now we have the dependent variable, we have the constant, and we have the experience years. So you need just to click here on OK. And here we go. Congratulations. You already created your first simple linear regression. Let's have a look at the results. You will see here that we got the constant here. This is the coefficient of the constant, which is 2576.31. And this is the prediction for the minimum salary. You remember that we say that if there is no impact of the independent variable on the dependent variables, let's say it's 0, assume it's 0, this will be the minimum here, which is the B0. So Y will equal to 2576.31 in case that years of experience is 0. But here we got something also for years experience is not insignificant, it is significant. So the coefficient for the years of experience is 402.209. And let's have a look at the p-value, and that's what we need to check. First, the p-value. So let's go to the right and have a look at the p-value. So we already got the constant, forget about the constant. Let's go to look at the independent variable. And you will see here that the independent variable is 1.60 E minus 06. E minus means that this is a scientific number. And when it is in minus, that means this number 1 will go to be a decimal for 6 digits. So it will go something 1, so we'll get 0, 0, 0, 0, 0, 0, 6 zeros, and after that is 1 and the rest of the number. In other words, this variable is highly significant because the p-value here is much less than the 5%. It is very small compared to the 5%. And that's why we find here 3 stars. That means it's very significant. If there are 2 stars, that means is significant but not very significant. And if we have 1, it will be little bit significant. And if we don't have any stars, that means that variable is insignificant. But with these 3 stars, that means this is very significant, and there is an impact of the years of experience on the salary. And let's see what is the prediction power of this simple linear regression model. Let's go and read here. We got R squared 0.95%. It's so high, it's very close to be 100. And the adjusted R square is 94%, which is still very high. So we can say that this model is very powerful model because it is explain 95 or 94% of the change in the dependent variable, which is very high. And this is, of course, also is very rare to find this kind of regression model to be so high in this situation. And we need to understand the coefficients also. In case that we don't have any impact on the years of experience, or let's say that somebody come to the company with 0 years of experience, that employee will start with 2,576 salary. Let's explain what is the meaning of this coefficient 402. So any year we add to the employee's experience, we'll add 402 salary to that employee's salary. So 5 years, that means we're going to multiply 5 by this number. So that's how the regression model analyzed the data that we have. So you should understand an increase of 1 unit in the years of experience, and the unit here is 1 year, is not 1 month. We are using here the yearly experience. We are taking the experience in years. So that's why the unit here is 1 year. So 1 year extra, that's mean 402 extra in the salary. And this is simply how to interpret the results of the simple linear regression.